Hello, everyone. Welcome back. Today, we're going to learn about quadratic functions, specifically about quadratic functions in what's called vertex form, which we'll explain. So our goals for today, be able to find the important values of a quadratic function in vertex form, being able to use the equation itself and what we can get from that, and also be able to graph a quadratic function when it's given in vertex form. So first off, let's take a look at what we mean by vertex form and also a quadratic function. So let's take a look at this function right here. And it's quadratic because you see here's our x, and our x, the highest power x is going to be raised to is going to be squared. That's what makes it a quadratic function. So let's talk about quadratic functions that look like this, what this is called vertex form, and see why it's called a vertex form. So first off, if we graph this, the graph of a quadratic function, any quadratic function, no matter what form it's in, is always a parabola. Now, we're in this form, the vertex has coordinates h and k. Here, our h has the opposite sign as you see in front of it. So in the formula in the equation, if it's negative, then the x-coordinate is positive. If it's positive here, the x-coordinate is negative in the vertex. And then k is the y-coordinate of the vertex. It has the same sign as seen here. Now, so that's why it's called the vertex form, because we can easily, from this, written in this way, we can easily find the vertex. If you want to find the x-intercepts, you find that by setting f of x equal to 0 and then solve for x. Now, if you end up getting the square root part equals a negative number, and then or your solution is not real, which would be the same thing. It means you actually have no x-intercepts. The parabola does not cross the x-axis. Now, if the parabola has x-intercepts, the x-coordinate of the vertex is halfway between the vertex, the x-coordinates of the intercepts. Also, the a in front is important. It also tells us the sign. So if this a, which could be a 1 or even a negative 1, it could be something else. If it's positive, the parabola opens up. If it's negative, the parabola opens down. Also, if the parabola opens up, the y-coordinate of the vertex is a minimum value. It's this lowest point on the graph. And if the parabola opens down, the y-coordinate of the vertex is a maximum value. So once again, we're talking about the y-coordinate itself is what's called the maximum or minimum. The x-coordinate kind of tells us where it is, but it's the y-coordinate that's actually the maximum or minimum value. And also, a parabola has an axis of symmetry, which is a vertical line that runs to the vertex and has the equation x equals h. Remember, h is the x-coordinate of the vertex. So, after saying all that, let's take a look at an example where we can make some sense of this. So let's take a look at our first example. Let's say we have our function f of x, let's call this number 1. F of x is equal to x minus 3 quantity squared plus 2. So from here, let's find out what we can about the function, then we'll graph it below. So our vertex, that's the first thing we can find. So our vertex, the coordinates, so look here, this gives our x-coordinate, and it says it has an opposite sign of this. This is negative, so our x-coordinate will be positive. And here, this is our y-coordinate, it has the same sign, so it's plus 2. So our vertex of our parabola is located at the point 3, 2. Now our a, the number in front, is just equal to 1 and is greater than 0. So what this tells us then is that our parabola opens up. So we're going to know two important things about it, the vertex and whether or not the parabola opens up. Now, let's take a look what else we can find. And actually, I probably need to move this down a bit. I might move it too far. No, that's good. Now, one thing we also find our y-intercept. I didn't mention that over here, but your y-intercept is always found by setting x equal to 0. So the y-intercept, okay, So that's going to be f of 0, and that's going to be negative, or sorry, negative 0, but 0. Zero minus 3 squared plus 2. And if you do square that, that's going to be negative 3 squared. It's going to be 9 plus 2 is going to be equal to 11. And so the y-intercept, the coordinates, of your y-intercept are going to be 0 and 11. Now let's think about our x-intercepts, intercept or intercepts. So once again, what we do here then is that in that case, that's f of x equals 0. So if we plug our function into that, and so what that's going to be is we're going to have to solve x minus 3 squared plus 2 is equal to 0. Now, if we do this, then we'd have x minus 3 squared is equal to negative 2. And actually, this tells us already the solutions of this are not real. They're imaginary. They involve complex numbers because we're trying to take the square root of a negative number. Remember, at this point, how to solve this, we try to take the square root of both sides. If we do that, then the solutions are not real. So what that tells us then is actually there are no x-intercepts. Actually, give me a moment. We can actually get rid of that for now. We'll come back to that. And say then, so no x-intercepts. Okay, what else can we find? Well, we also know that we have a axis of what's called an axis of symmetry. And what that's going to be is going to be a vertical line. And your vertical line has an equation x equals a number. And this case is going to be x equals to the x coordinate of the vertex, x equals 3. Okay, so now let's put all this together and try and graph this. I can graph this all in the same graph. I have to shrink this graph a bit. It's not going to be completely clear, but you can always graph this on a graphing calculator or some other website, get a better idea. So if we find this, so we said our vertex is coordinates 3, 2. So 3, 2, right here, that's our vertex. Okay. And also, I forgot to say, so the minimum, we have a minimum value. So also, since the parabola opens down, or opens up rather, y equals 2, which is the y coordinate of a vertex, is the minimum value. So it's not the x coordinate, it's the y coordinate of the vertex is the minimum value. Now we also have remember, we have no x-intercepts. That makes sense. The parabola opens up, it doesn't cross the x-axis. We do have a y-intercept, which is a bit off our scale, but that's okay. We'll put it about right here. Okay, so that's going to be 0 and 11. Remember, this is 3 and 2. We also have this, what's called the axis of symmetry. This vertical line. X equals 3. That's our axis of symmetry. So our parabola, if you draw it, looks something kind of like this. It's called once again axis of symmetry because it's perfectly symmetric, has exactly a mirror image. The graph is a mirror image on each side of this line right here, x equals 3. And so that's our graph. That's what we find from, we got all that from just this form. Now, briefly, let's look at another example. Briefly, we won't graph it, but we'll show a couple more features. So number 2, let's say we have this, f of x is equal to -2 times x plus 3 squared minus 5. Okay, so once again, we know this is still a quadratic function because my x, the highest power, will be squared. Okay, so let's see what we can find about this. This time our vertex, it's in the vertex form, so you can easily pick out our vertex. Our x coordinate you get from this. Remember, it has opposite sign. This is positive, this is going to be negative. And then this gives us our y coordinate and has the same sign, so it's -3, -5. Okay, now this one, our a, in this case, the number in front is -2, which is less than 0. That tells this parabola then opens down. Okay, now what else we find, among the other things, is that our, since parabola opens down, then y equals -5 is a maximum value. Actually, hang on. I realized I wanted to change something. Let's make this a +5 instead. Make this positive. Sorry about that. So let's get rid of the there. Okay. Now, the reason I'm doing that then is because we actually want to have x-intercepts. So y equals -5 is a maximum value. It's the highest point on the graph. Just as look this graph right here, this was 2 is a minimum value. That's the lowest point on the graph. The lowest value, smallest value is 2, the minimum. And this will have as a maximum value would be -5. Now, let's also find the x-intercepts in this case. Make sure that's clear. So to find the x-intercepts, we solve f of x is equal to 0. We do that then, we have our function f of x is -2 times x plus 3 squared plus 5 is equal to 0. Okay, so our goal is to get x by itself, so subtract 5 from both sides. We have -2 times x plus 3 squared is equal to -5. Then we divide both sides by -2. And so we have x plus 3 quantity squared is equal to, this time, +5 halves. -5 by -2, of course, is positive. Now, here, we use something called the square root property. It has the effect of taking the square root of both sides. So if this is true, then x plus 3 must be equal to plus or minus the square root of 5 halves. Now, that plus or minus is critical because if I square either a negative or positive value, that will give me, if I square both sides, that will make this true. Okay, then finally, x is equal to -3. Get x by itself, plus or minus the square root of 5 halves. So then my x-intercepts, I have 2 x-intercepts because I have the plus or minus. So remember, these are the x-coordinates. So one is -3 plus the square root of 5 over 2. Oops. And of course, our y-coordinate is 0. And then the other one is just with a negative value. It doesn't matter which one you put first. The other one's going to be -3 minus the square root of 5 over 2 and 0. Then you can always approximate those and find those values. And you also find the axis of symmetry. But here I just want to make sure it's clear what happens when we also have one who has a maximum value, and then also we have the x-intercepts. Now, let's look at one more example. And this time what we have is we're going to go backwards. We're going to start with a graph and then make sure that we can, oops. Sorry, I'm going to have to get rid of that. I actually realize what happened. I need to just start down here. Actually, probably enough space here. There we go. Move this over. And then let me actually delete this up above. So give me just a moment. Let me fix all this. That's why. Okay. Now, what we're doing here then is this time we're given the graph. And so what we want to do then is here, in this case, as you might expect, then find the equation of the quadratic function in vertex form. Okay, so let's pick out a few things we can see. So what we want, first off, we're going further, is we want something that looks just like this. We want an f of x is equal to a times x minus h squared plus k. That means what we need to do then is we need to find a, h, and k. Now, the good news is we can find all those, what we're given. So first off, we see that our vertex is right here. And that's given to us, which is -2 and 3, okay? So if we plug those in, what we have so far then is f of x is equal to, remember here, it's going to be x. Remember here we said that we're going from the vertex to here, it has opposite sign. This is -2. It means it's going to be +2. This is going to be +2 squared. And the y-coordinate has the same sign, so +3. Okay. So, oops, we still have our a. Okay, good. So we found h and k. Now we need to find a. So to do that, then we're going to use the other point we're given. So it shows the graph goes through 0, 0 through the origin. What we're going to do then is actually plug that in. We'll plug in this point, plug in 0 for x and 0 for y. And as we'll see, then all we have left to find is a. Okay, so y then is the same as f of x. So we have 0 is equal to a, which is an x, which is 0 plus 2 squared plus 3. Now we have an equation we can solve for a. So we have 0. This is going to be 2 squared plus 3. Let's go move the 3 on the other side. So that's going to become -3 is equal to, of course, 2 squared is 4. 4 times a. So a, we divide both sides by 4, is -3/4. And so our equation is f of x is equal to -3/4 times x plus 2 squared and plus 3. Now we can also tell some other things from the graph and also from this once we have it. So actually from here, from our picture, we can actually tell a few things. Of course, once again, now since this parabola opens down, 3 is our maximum value. We also have an axis of symmetry that runs right through here, which would be the equation x equals -2. Okay. So we can also tell some things from the graph itself and also from this. And then we get the equation. All right. So what we've seen so far is today is a quadratic function in what's called vertex form. Okay, this is not the only form, but this form is really useful because once again, we pick out a meter what the vertex is and find other useful information, which allows us to graph it by hand. We can always verify that we have everything correct by graphing it on a graphing calculator or something like that. So we can get that information. Then also, if we're given the graph, we can also, if we know the vertex, at least one other point, we can always find the equation of the quadratic formula in vertex form. Thank you. Have a good day.